Okay. Today, another section, inverse trigonometric functions. Now, we don't want to confuse this with reciprocal functions, right? The reciprocal functions are the cosecant, the secant, and the cotangent. Today, something different, inverse trigonometric functions. So let's talk about what an inverse trigonometric function is. Now, what do we know about inverse functions? How can we tell whether a function has an inverse or not? By applying what? Y'all remember? No. You remember the vertical line tests whether we have a function, but the horizontal line tests us whether we have a what? Inverse function. So, if we look at the sine curve, let's look at the sine curve. If we look at this sine curve, does that pass the horizontal line test? He says negative. I guess that means no. It does not on its whole domain, okay? But if we restrict the domain, then possibly it will pass. For instance, if we look from negative pi over 2 to positive pi over 2. If we look at this portion from here to here, if we restrict the domain to the yellow portion, does it pass the horizontal line? Or does the horizontal line test pass then? It does. So, that leads us to believe that some of these trigonometric functions will have inverses, but on a restricted domain. Okay?
What is the horizontal line test again?
The horizontal line test, that means that if I draw horizontal lines, I should only touch that graph in one place.
Okay.
And on the yellow part that happens, but on the rest of the graph, it won't. So that's why we have to restrict our domain. Okay? Now, so that leads us to believe that we have inverse functions on restricted domains. So let's look at a definition. And this definition will give us a definition of inverse functions for sine, cosine, and tangent. So if we have the function and look at the domain, we can look at the range. So the function, and the way we denote the inverse function of sine is y equals arc sine x. Arc sine on your calculator may be sine to the negative first power, maybe the second function in sine. Do you see that sine to the negative first power? Same thing as arc sine. That denotes the inverse function. So y is equal to arc sine x if and only if sine y equals x. Pretty much that's the definition for arc sine, and we're going to look at some things in more detail. The domain for arc sine x ranges from 1 to negative 1, and the range y will range from negative pi over 2 to pi over 2. So, we know that when we talk about inverse functions, the domain of the original function takes on the range of the inverse function. The domains and ranges are switched. But here, because we know the range of the original sine is between negative 1 and 1, right? The maximum and minimum. So that becomes our domain. The domain of the original sine function was our numbers. But we need to restrict it here so that it passes the horizontal line test. Which means that arc sine is defined only in quadrant 1 and quadrant 4, right? 0 to pi over 2 is quadrant 1. Negative pi over 2 to 0 is quadrant 4. So that is the only two quadrants where arc sine is defined. Y equals arc cosine x if and only if cosine y equals x. Now, here we're not going to go through with the picture there, but cosine on its original domain will not pass the horizontal line test. But if we restrict it to be between 0 and pi, then it will. Okay? So arc cosine is restricted between 0 and pi, which means that arc cosine is only defined for what? Quadrants 1 and what? 2. Okay? Quadrants 1 and 2. And y equals arctangent x if and only if tangent y equals x. Now we know that the range of tangent went all the way to negative infinity, positive infinity, because we had those vertical asymptotes. It means that its domain will also range from negative infinity to positive infinity. And we restrict tangent on this interval from pi over 2, negative pi over 2 to pi over 2. Notice that these are strictly less than because negative pi over 2 and pi over 2 produce what? Vertical asymptotes, so they're not defined at those points, so they cannot be part of our range. So tangent, arctangent is defined for quadrants, what? 1 and 4. Okay? That will become important to us as we go on and do problems dealing with these things. Now, what does this stuff really mean? Okay? Let's do some examples without a calculator. The first one, suppose we want to evaluate arc sine of 0. And let's talk about how do I think about how to do this problem, arc sine 0. Well, if I get it in this form, y equals arc sine x, then I can translate it to that form. So let me say that arc sine 0 equals some y. What that means by this statement is that what? It says y equals arc sine x if and only if sine y equals x. So here, y equals arc sine 0 if and only if sine y equals 0. What this means is, and this is what we should think to ourselves, I need an angle in this range from negative pi over 2 to pi over 2 that has sine value 0. This is what that means. I want an angle, y, between, what's my range? Negative pi over 2 and pi over 2 that has sine value 0. So, I bring out my little sheet again. What angle between negative pi over 2 and pi over 2, that means we're dealing with a first and a fourth quadrant angle, has sine value 0. 0. Okay? Remember, on this unit circle here, the first value is cosine, the second value is sine. So this means that y equals 0. That is the angle in this interval that has sine value 0. So you have to remember arc sine, quadrant 1 and 4, arc cosine, quadrant 1 and 2, arc tangent, quadrant 1 and 4. Okay? We have to get the quadrants right here. Okay? Because there are other values that have sine 0 that may occur in quadrant 2, 3, but we need an angle in quadrant 1 or 4. So look at another one. arc cosine 0 equals y. What does this mean? This means that I need some angle y that has cosine value 0 in which quadrants? Which quadrants? 1 and 2. So I look at this, quadrant 1 and 2. What value gives me cosine 0 in quadrants 1 and 2?
Where are you getting quadrant 1 and 2? Why did you get
The range here, okay? Quadrant 1 goes from 0 to pi over 2, and quadrant 2 goes from pi over 2 to pi. So from 0 to pi gives me quadrant 1 and 2. And we're dealing with arc cosine, so it has to be an angle in quadrant 1 or 2. This, 0 to pi over 2 is quadrant 1, and negative pi over 2 to 0 is quadrant 4. So that's why we look at 1 or 4. Okay? Somebody else? Mm-hmm.
On that first one, though, it was a sign. How did you get the 0 if it was a sign? Is it pi over 2, wouldn't it be the 1?
No, this one, no. We're looking for an angle. The question is, why do we get this 0? Here we're looking for an angle between negative pi over 2 and pi over 2 that has a sine value of 0. And that angle is 0 radians. 0 is the angle there.
I don't see a negative pi over 2.
Okay, you don't see negative angles. What the negative angles mean is that you start with 0 and you go, clockwise? So what that means is that 11 pi over 6 is the same as negative pi over 6. Or what? Pi over 4, if you go around, it's the same as, or 7 pi over 4 is the same as negative pi over 4. Remember, all these angles have, many different representations. So 7 pi over 4 is the same as negative pi over 4. You just go clockwise. Is that making sense? Yes?
What were the quadrants again? Like sine was quadrant 1 and 4.
Mm-hmm.
Quadrant 1 and 2.
This is 1 and 4. This is 1 and 2. And this one is, 1 and 4. Other questions before we go on?
Is that chart in the book?
What chart? This?
That where you just do the function, domain, range. Because mine looks kind of floppy and I might get confused by it. Is it somewhere in the book? 324.
Oh, okay. Okay. So, what angle has cosine value 0 between what? In quadrants 1 and quadrant 2. What angle is that? Pi over 2. Okay? Pi over 2. Let's do an arc tangent. Arc tangent negative 1. So what this is saying is, what angle has tangent value negative 1 in quadrant what? 1 or 4? We know it's not quadrant 1. Why? Because quadrant 1 tangent is positive, right? X's are positive, Y's are positive. And being that we have tangent negative 1 means we're going to be in quadrant 4. So, how do I know what that is? Well, I look in quadrant 4. Tangent is sine over cosine. I need to find that angle where sine and cosine have the same absolute value but different. He says it's 7 pi over 4. It is 7 pi over 4, but 7 pi over 4 is really not in that interval. So we need to get what? A coterminal angle, a negative angle, which is what? Is negative pi over 4. So remember, yes, 7 pi over 4 is the angle that you come to, but you need to think to yourself, well, 7 pi over 4 is not in that range. What is another name for that angle in that range? And it is negative pi over 4. Let's say that again, okay? We said that here we define an angle in quadrant 1 or 4 that has tangent value -1. We know it's not quadrant 1 because what? Positive. So it's in quadrant 4. So we can look, and 7 pi over 4 is the value that will give us that quotient of -1, right? In quadrant 4. But we can't say quadrant 4. We can't say 7 pi over 4. We have to get an angle in this range. So we need to get the negative representation of that angle. So if we look at 7 pi over 4, and we go from 0 down to 7 pi over 4, if you draw a vertical line down from pi over 4 to 7 pi over 4, they represent the same angle, but it's what? Negative pi over 4.
I was looking for -1.
No, remember, tangent is sine over cosine. So that ratio gives you -1. Remember, tangent is sine over cosine, or what? Y over x. And in order for us to get a quotient of -1, y and x are going to have to be the exact same value. And they're both. One is -√2/2, and one is √2/2. And that gives us a quotient of -1. Okay, let's go to the calculator now, and let's see how we can do these things on the calculator. No, this is all you're going to be given, this right here. So there's still a whole lot of stuff to learn, lots of stuff to learn. So now, let's use our calculator to evaluate arc sine 0.45. Now, first of all, notice these arc sines, arc cosine, arc tangent are defined for what? Radians. So your calculator needs to be in radian mode. Okay? Needs to be in radian mode. Now, what does this mean? Remember I said at the beginning, the inverse functions may look something like that on your calculator. Sine to the -1st of 0.45. Do we see that button on our calculators? Should be second function sine or something. So do that, second function sine, or sine to the -1st power, 0.45 in radian mode, and tell me what you get.
0.467.
Okay? 0.47. Did we not get that? It's not? It should be to do these problems. I don't know how to get it there, but we do need to know.
Mode button. And go down, it says radian or degrees.
Okay, she may have a different calculator. She has a different one, looks like.
Oh, okay, never mind. Sorry.
So, it needs to be in radian mode, though. It needs to be in radian mode when you do these things. So everybody would count everybody else. Did we get that 0.47? Okay. And arc cosine is cosine to the -1st. Arc tangent is tangent to the -1st. Okay? So let's look at another one. Arc cosine -0.7. We should ask ourselves, though, is that in the range of the function? Here 0.5 is, 0.45, here 0.07 is. Because if it's not in that range up there, then we cannot get a value for it. So what is that? Did you do our cosine? Which should be cosine to the -1st of -0.7. What did you get there? Should get 2.35. Did we get that? Somebody said yes, somebody said no. You got it? Okay, that's good. We're getting it? Okay. This is just good. She got it. All right, so this is an exercise on how to use our calculator and what these things look like on the calculator. Okay? Now let's look at some inverse properties. inverse properties. The first one states if x is between -1 and 1 and y is between -pi/2 and pi/2, then if we put sine next to arc sine, then we'll get x back. Kind of like when you compose a function with its inverse, you're to get x back. And if we compose the other way, if we have arc sine of sine y, then we should get y. So what this is saying is that if we are in the proper domains and ranges of these functions, then just like with these inverse functions, you should get x back when you compose them both ways. Y'all remember that from 112? We can state a similar property for arc cosine and arc sine and arc tangent. Here, if x is between -1 and 1, and y is between 0 and pi, then cosine of arc cosine x equals x, and arc cosine of cosine y equals y. So again, if you have the proper domain, the proper range, composing those two functions will give you back x. And number 3, we can get a definition for tangent. Here, x can be any real number. If x is a real number and y is between -pi/2 and pi/2, then tangent of arctangent x equals x, and arc tangent of tangent y equals y. Okay? We can compose those inverse functions and get just plain old x back. What it means for functions to be inverses. All right. Look at some examples. Let's evaluate sine of arc sine 0.3. If we go back to our inverse properties over there, we have to be in the correct what? Domain here. We have to be in the correct domain. Notice sine comes first. So we have sine of arc sine x. That x needs to be between -1 and 1 for us to be able to evaluate this. Is that x between -1 and 1? Yes, it is. So what is sine of arc sine 0.3? Just 0.3. We just can't say 0.3. We have to make sure that that x is in the proper range, or what? That y is in the proper range. How about this one? Tangent of arctangent 25. So does this 25 represent x or y? By that property over there. Tangent of arctangent of what? X. This represents x. Is that in the proper domain for x? Yes, because here all x's must be a real number, so x is 25. Okay, when we have tangent of arctangent, then by that property, this is what? X, right? So I need to see, is this x in my range for x over there? Yes, it says number 3, if x is a real number. It can be any real number, so it's okay. How about this one? Arc cosine of cosine 7 pi over 2. Now, notice my arc cosine is first, right? And when arc cosine is first, then this represents y, right? Is that in the range of my y for arc cosine? Think about it. Arc cosine goes from 0 to pi. Is this between 0 and pi? No, it's not. This is not in my domain or my range. But can I find an angle that is? She says yes. So let's think about this. 7 pi over 2 is coterminal to what? 3 pi over 2. Okay? It's coterminal to 3 pi over 2, but 3 pi over 2 is not in there either, is it? Is it? No. 3 pi over 2 is not between 0 and pi. But nevertheless, cosine of 3 pi over 2 equals what? 0. So I need to find an angle in that range between 0 and pi that has cosine value 0. Do I know what that angle is? Pi over 2. So this is the same thing as saying arc cosine pi over 2, which is what? 0. Let's say that again. 7 pi over 2 is not in that domain. Let me find a coterminal angle, an angle that have the exact same, value. That's 3 pi over 2. Okay?
That means looking on the unit circle and seeing how many units up that was and then going down that many units in the opposite direction.
Or subtracting or adding 2 pi.
It would work either way.
Yeah, because that's what that means. You have the same terminal and initial. You can go around several times, But this 3 pi over 2 is not in that interval either. But what value of cosine have the same value in that interval, and that's pi over 2. Or there could be another way to get to that. 7 pi over 2. You could do 7 pi over 2 minus 6 pi over 2. Well, no, that's not 2 pi. That's 3 pi. But that gets you... It's not. 7 pi over 2, it's not in there, is it? It's not, but because it's bigger than 2 pi, right? 7 pi over 2 is what? 2 goes into 7, 3 with some left over. So that's why you define the coterminal 2 is not on the unit circle. But you can find something on the unit circle that's coterminal to it because it's bigger than 2 pi.
Oh, okay. So you just keep adding.
Or subtracting.
So why is it when I plug into my calculator 7 pi over 2, I actually get a number? Because in other times I get, domain.
Okay, let's talk about the range and all that. Okay, when you find an inverse function, it has to pass the horizontal line test, right? For instance, if we think about f of x equals x squared, doesn't pass the horizontal line test, does it? But yet you can find an expression that could be an inverse, but that expression you find is not an inverse function. What you find may not be a function, but you can find an expression. So we're not saying that we cannot find an expression for these angles, but on that domain it will not represent a function, which means for every x and y there is a, that, okay? So, and I don't know how in depth your 112 teacher went with that, but just because you said what you said was that this function does not have an inverse function, which means that the expression you got was not a function. It didn't mean that you couldn't find an expression. It's what you found was not a function. Does that make sense? Okay? And a lot of people don't thoroughly explain what that means when you find an inverse function. Because it may not have an inverse, and you can still find an expression that you think should be the inverse, but it won't be a function. Okay? Now, let's look at some other examples. Yes, thank you, pi over 2. The answer here is pi over 2, not 0. We just need that 0 to find it, pi over 2. Okay, we want to use an inverse trig function to write theta as a function of x. This is the directions for the next few examples. Suppose we are given this picture. Suppose we're given this picture. Well, we are given theta, we're given that this is x, and this is 4. And this is all that we're given. Okay? And they want us to use an inverse trig function to write theta as a function of x. So we want theta equals to something. Okay? Now, by what I have here, this is a right triangle. I'm given in relationship or respect to theta, I'm given the adjacent side, and I'm given the hypotenuse. So what do I know about adjacent and hypotenuse? Cosine theta is adjacent over hypotenuse, right? Cosine theta is adjacent over hypotenuse. And what they want us to get is theta equals something where that something contains an x. So how can I get theta over there by itself? Well, if my domains and everything are in order, I can apply arc cosine to both sides. And arc cosine and cosine will give me theta, because that cancels out by inverse function, equals arc cosine 4 over x.
How did you do that?
Okay?
Why don't you just divide by
Divide by what?
theta?
Cosine and theta are attached at the hip, and you can't separate them unless you got an arc cosine in front of it. They're attached. They go together. It's not like x and y. You can just divide by y. Cosine, well, theta is the argument of cosine. They go together. And the only way you can get that theta away from that cosine is to apply this arc cosine using that property, and that gets that theta away. Does that make sense? You just can't divide or multiply. It goes together.
So to get rid of the cosine and theta, or to get rid of the cosine in front of theta, you have to multiply the arc cosine?
You have to apply. You're not multiplying. You are applying arc cosine to both sides.
So then that kind of crosses out the cosine in front of the theta.
Right. They, once you apply it, what you're doing is you are composing that function. You're really not multiplying. Remember, multiplication and composition of functions are not equivalent. When you compose that function, this will undo that cosine, all going away to leave theta. Use an inverse trig function to write theta as a function of x. And being that they want to use an inverse trig function, we need to use the only inverse trig functions we know: arc cosine, arc sine, arc tangent. So, excuse me, we have to get from this triangle this thing in terms of cosine, sine, or tangent by what's given, and then apply the arc tangent or arc cosine or arc sine. Let's look at another one. Let's look at another one.
I didn't know you use the X instead of Y now. Or you should the X.
This is given. This triangle's given.
I mean, like, you chose the arc cosine times the cosine of theta instead of the cosine times the arc cosine of theta.
Oh, because here we were given. You need to find this based on cosine, sine, or whatever. Here we're given the adjacent, the hypotenuse, so this means cosine. So in order to get rid of that theta, I have to apply the inverse, which is arc cosine. Because arc cosine, we don't know what that is based on x, y, hypotenuse, adjacent, you know. It's just defined the way we define it today, based on the sine, the cosine, the tangent.
Do they give you the cosine of theta equals 4 over x, or you have to get that from the picture?
You get it from the picture.
You have to write that on your own.
Let's look at another picture. This is theta. This side is x minus 1. This side is x squared minus 1. So I'm going to let you tell me what to use. What are we given? So what do you think we're going to use? Tangent. Tangent theta is opposite over adjacent. So,
Can you break that up and then...
yes,
Can you simplify that?
you can, and we're going there.
Okay.
We're going there. How do I get theta over there by itself? What do I apply?
Arc tangent.
Arc tangent. So this means theta is what? Arc tangent. And now let's simplify. We can factor that denominator, x minus 1, x plus 1. But we have to say, you remember when we cancel that out, we need to say that x cannot equal 1. Right? Because there is a restriction. We're canceling that out, but x still can't equal 1 even though we're canceling it out. Okay? I forget what that's called. Yeah, but you have to state that x cannot equal 1.
Why can x equal 1?
Because if you put 1 here, you get 0 in the denominator, right? And even though you cancel it out, you may get something that's, is it called extraneous? I'm trying to remember. Is that what it is? I think it's called extraneous. You may get something extraneous because here, putting 1 just in this portion, it works. But it doesn't work in this portion where you have, in the original problem, where you cancel that out. So you have to state, whenever you cancel an algebraic expression out of the denominator, you need to say that it cannot equal whatever x would be to make the 0.
Okay, the negative 1?
Well, here, it's still there. So if we put negative 1 in here, we'll get 0 in the denominator.
So when we put 1 in, sorry.
So what that means is that, no, it cannot equal negative 1, but if I put negative 1 here, I'm going to get a 0 in the denominator, and I can stay undefined. But if I put 1 here, I'm going to get a 1/2. But 1 still won't work because of the original problem. We cancel some stuff out.
You put 1 and 1 negative 1?
No, just put what you cancel out, whatever makes that 0 from what you cancel. So just 1. X cannot equal 1.
But if in the original function x was negative 1, it would still be 0 in the denominator.
Yeah. So they're just supposed to put both of them.
You can, okay, you can put both. It's not necessary, though, because once you put in, if you were to put in negative 1 here, it would give you that. But if you put in 1 here, how would you know if we didn't state it. So it's okay to cover yourself. You can put them both. You can put them both.
So if we leave that out, then the answer's wrong.
If you leave this out, yes, it's not totally correct.
Would you count it wrong on a test? Or would you take out partial credit?
Partial credit. I'd take off some partial there.
But you look at the first, the x squared minus 1 is really where you start.
But whatever you cancel out, that's what you need to say, you know. Because down here we can go and put in 1 now, but 1 still won't fit in the original problem. Right. Do we have other questions? All right. Let's look at some more problems. Let's find the exact value here. We want to find the exact value, which means what? You really don't want to use a calculator. Suppose we have secant of arc sine 4/5. And we want an exact value, so we can't use the calculator. Secant of arc sine. I've never put those things together, right? I can put what? Sine next to arc sine. I know that can go away, but how do I do a problem like this? Well, we're going to do some substitutions. If we let u be this portion, arc sine 4/5, let u be what's in parentheses there, okay? Then, how can I get rid of this arc sine? By applying what to both sides? Sine. So that means sine u is sine of arc sine 4/5. So sine u is what? 4/5. Does that make sense? Okay. We're going to replace what's in parentheses by u. Okay? And let's just look at this u. If we let u equal arc sine 4/5, then what I want to do is get to something where I can identify what x is or what y is or what the hypotenuse or whatever. I want to get to where I can identify those things. So, if I apply sine to both sides, then sine u is 4/5. And what that means is that I have a little triangle that I can draw with u. Sine is what? Opposite over hypotenuse, right? Right? But I want secant of u. Really, right? And what is secant? Secant is hypotenuse over adjacent. I know hypotenuse. Can I find adjacent? Can I find adjacent? What is adjacent? What is adjacent? We'll call this x. Adjacent is the square root of hypotenuse squared minus opposite squared. 25 minus 16, square root of 9, which is 3. So x is going to be what? 3. So my secant u, what is secant? Hypotenuse over adjacent. Okay? So I want to find secant of arc sine. I need to break that down to where I can get to a triangle. Okay? I need to break that down to where I can get to a right triangle, identify what's given. I may need to find the other component to find the secant of that. It seems far out there, it seems weird now, but you will find these will be the easiest problems that you could possibly have.
So which, do you want the secant u answer, or do you want the sine u?
No, we want this. This is the answer.
Okay.
Secant u.
So do you really have to do all that to get that, or could you just have started with drawing the picture out, like with what you were given?
But if we had just drawn the picture out, what would we have known to draw? If you think about it, we take this and work with this to find out what to draw.
Well, so the sine is opposite over adjacent, so wouldn't you just know?
Somebody may not just know. Somebody needs to know where it came from, though.
I just see it. Okay.
You may see it that way, though, and that is the correct way to see it.
On a test like that? Or would you?
If I can see where you're going, I'm not so picky. If I can see where you're going, and if you're going somewhere that's algebraically correct, I'm not so picky.
What did the let u equal arc sine 4/5? What did that do for us in the problem?
This got us to this triangle, so that we can figure out what secant of this thing is. Let's look at another one. Let's look at another one. Let's find sine of cosine to the negative first, which is another way of saying what, class? Arc cosine. Okay? So, how would I start this problem? How would I start this problem? And I want an exact value. Can't use my calculator.
U equal arc cosine.
Right. And if you didn't say that, how would you start? How would you start? You need to say, let U be this portion that's in the parentheses. You need to start off that way. Because this is going to tell us how to get to sine. Because sine is what? What's sine? Opposite over hypotenuse. So we need this triangle. We need the triangle. Now, this is U, then how do I get rid of this inverse cosine? By doing what? Well, inverse cosine and arc cosine are the same thing. Just two different ways of writing it. So I need what? Just cosine. We have to remember that, hey, I have two notations. Arc cosine and cosine to negative first power are the same thing. So here I have cosine U is the square root of 5 over 5. This is how I draw my triangle. If this is U, what is cosine U? What is cosine U? Adjacent over what? Hypotenuse. What do I need for sine? Opposite over hypotenuse. So I need those components to find what? The other leg, opposite. So what is opposite? Opposite is the square root of the hypotenuse squared minus the adjacent squared.
Where are those formulas
The Pythagorean, they're all on this page. Pythagorean identities, right? Is that where it is? No, it's not. Is it?
This is the top left.
Top.
Top left, which are
No, he's asking about the opposite. That's a Pythagorean theorem, right? And that's not really on here.
Use it right there on that first one, 5.
The hypotenuse squared is the opposite squared plus the adjacent squared. That's not anywhere on that sheet of paper, but that's the Pythagorean theorem that we should know. Okay?
Why does it say 5 squared minus?
Because we're finding the opposite. So from here, opposite is the hypotenuse squared minus the adjacent squared, and then the square root of that whole thing. This is the original formula. We need to get it into what? Where we have opposite, we solve for opposite. Okay? Pythagorean theorem. So, what is this? The square root of 25 minus 5, which is the square root of 20, which is what? Square root of 4 is 2, square root of 5. Which means that sine of this thing, sine is what? Opposite over hypotenuse. Opposite over hypotenuse. So as you can see, y'all, this U stuff, as y'all say, I mean, it's easier if you use it, you know. You need U. You need U. You have to make these substitutions. Huh? Are we almost done? And you know what? This goes to show you, I thought this would not be as hard as some stuff for you. But it seems like it's harder than some of the stuff we've done. Seems like. I thought today would have been an easier day, you know. Okay, all right. Let's look at some more. A couple of more. Write an algebraic expression that is equivalent to the expression that's given. But I don't know. You know, it seems like whatever I think should be easy for students, they find it hard. And what I think should be hard, maybe you find it easier. I don't know. But these are the directions. Write an algebraic expression that is equivalent to the expression that's given. Suppose we're given that sine equals arc tangent x. This is very similar, though, to what we've done there. Very similar. But where we see values, we see what? X's. So what does this mean? If we let u equal arc tangent x, right? Let u equal what's in parentheses. Then what? Tangent u will equal what? Pretty much. Let me not skip a step. Tangent of arc tangent x. So tangent u equals now what? X. Does that make sense?
Yes.
If we let u be what's in parentheses, then I can get to x by applying tangent to both sides. So tangent u is x. Or really, tangent u is x over 1, right? Because when I go over here and I draw my triangle, tangent is what? Opposite over adjacent. And I need to find what? Because I need sine, I need what? Opposite over hypotenuse. I need to find hypotenuse. And what is hypotenuse? Hypotenuse is the square root of what? Opposite squared plus what? Adjacent squared, which is the square root of x squared plus 1, which means sine u is opposite over hypotenuse. Now this one I'm not going to make you rationalize, okay? I'm not going to make you rationalize that. You can leave it as x over the square root of x plus 1. So can we see, these problems look similar to those problems, whereas we had actual numbers there, we have what? Algebraic expressions here. One more. Yes, and then we're done. We are done. Let's look at secant of arc sine x minus 1. So we let u be arc sine x minus 1. But really, x minus 1 over what? 1, right? So if we put the sign on both sides, we have sine u equals x minus 1 over 1. Well, what is sine? Opposite over hypotenuse. But what is secant? What is secant? So we need adjacent. So the adjacent side is the square root of the what? Hypotenuse squared minus the opposite squared. So a little algebra comes into play. What is x minus 1 squared? X squared minus 2x plus 1? 4, right? Okay? So this is what? If I distribute, I get negative x squared plus 2x minus 1, but that cancels out with that 1, right? So what I have is the square root of 2x minus x squared here. And what did we say secant was? Hypotenuse over adjacent. And this, I'm not going to make you rationalize, okay? This is the end of this particular unit, the first unit in this course.